you are using a quarter wave transformer for impedance matching is here, where a transmission line has a certain ZL here and a Z in here, which is to be matched to 50 ohms because this is carrying 50 ohms. Here, the Z in, you want it to be 50 ohms, but the load that you see, the amplifier load that you see is going to be something else. So you want to design this guy, the impedance of this line, so that the ZL matches to Z in. As I see it, it's going to be 50 ohms. How do we go about doing that? The transistor has 50 ohms input impedance. So ZL is going to be, 25 ohms input impedance. And the operating frequency is 500 megahertz. Find the characteristic impedance of the quarter wave transformer. The per unit length inductance of the quarter wave transformer is determined by, so this is L dash. What should be the C dash? That's the other part of the question. Let's do part 1 of the question, which is my line is going to be square root of Z in ZL. This is what we need to figure out. ZL is 25 and Z in is 50 because I want to match it to what is feeding in here. This is 50, so I want to match it to 50. So that means my ZL should be 35.35 ohms. But then my L dash is given in the question. I want to find the C dash. Because I know the Z line from the first part, I can go ahead and figure out, since Z line is square root of L over C, I can go ahead and figure out what is my C dash. And that would be 118.6 picofarad per meter. So C dash is a question mark that can be figured out this way. Once you figure out the Z line, the line's characteristic impedance. Determine the physical length of the section. So that becomes the beta L, or you might want to find the phase velocity, which is 1 over square root of LC, L dash C dash from the transmission line analysis, which is 1.5 into 10 power 8 meters per second, which should be less than C, by the way. Then you can go ahead and figure out your length to be lambda by 4. My VP is F times lambda. F is given as 500 megahertz. So I can figure out my lambda. So I can figure out my lambda by 4. So this is going to be VP over 4F, which is 4.75 centimeters. So this is going to be 7.5 centimeters long. So you can use a quarter wave transformer very easily when you're matching a resistive load to a resistive characteristic impedance. Characteristic impedance typically that you're matching to is always 50 ohms. So matching resistive impedance is very easy in that sense. Important catch is we are doing it at 50 ohms so that this length is lambda by 4. At some other frequency, it may not have that good kind of match. It only works at 500 megahertz.